Hello and welcome to solving quadratic equations by the square root property. Right, for this you need to know the rule that if x squared equals a needs to be greater than or equal to 0, and if that happens then if you take the square root of both sides you're going to have x equals the square root of a, or you could even have x equals a negative square root of a. The reason that we want a to be greater than 0 is, say if you had x squared equals a negative 49. Well, when you take the square root of both sides, you're going to get x equals something with a negative inside the radical. And that's going to give you something you'll learn later on as a negative, or an imaginary number. But for this case, you just need to know that it will not work. So just make sure that you have a negative outside of the radical, but never inside. Okay, so let's take some hands-on approach to this. We have, for this first example, x squared equals 36. Well, as we learned in that rule, if we are to take the square root of both sides, that's going to, on the left side, that's going to free the x squared to just make it x, equals, and what happens when we take the square root of anything, we get two answers. We get a positive and we get a negative answer. And that 36 is a perfect square, so when we take the square root, we're just going to be left with 6. So that can be written as x equals plus or minus 6, or it can be written as x equals 6 and x equals negative 6. And this kind of thing makes sense because if you were to look at the graph, you would see that it would strike at two places, at a positive 6 and a negative 6. Okay, if we look at number 2, we have x squared equals 1 over 81. So if we were to take the square root of both sides of the equation, that's going to free the left side to just be x, since the square root and the squared are inverses of each other. Okay, and we're going to be left with x equals the square root of 1 over 81. Well, as you have learned from previous classes, that you can break that into x equals the square root of 1 over the square root of 81. And to simplify that, we know that on top it's going to become 1 over, and the square root of 81 is 9. And remember, since we're dealing with square roots, that we have a positive and negative answer. So that can be written as x equals plus or minus 1 over 9. Or you can even write it separately as x equals 1 over 9 and x equals negative 1 over 9. Okay, with number 3, we are adding a little bit more to the problem. We have the quantity x plus 4 squared equals 100. Okay, so what I would suggest doing first is to get rid of this squared so we can actually work with stuff inside that quantity. So to get rid of that squared, take the square root of both sides. This square root right here and the squared are going to cancel each other out, leaving with what's inside, or just x plus 4. And on the right side, the square root of 100, well, remember we take a square root, we're left with a plus and minus answer. And the square root of 100 is 10. Okay, at this point, you can work the problem as you usually would by breaking it into two pieces. You can break it into the part x plus 4 equals the positive 10, and x plus 4 equals the negative 10. This will ensure that you get both answers. So in this first part over here, x plus 4 equals 10, to get x by itself, let's subtract 4 on both sides of the equation, leaving you with x equals 10 minus 4, where x is equal to 6. On this other piece of the problem, we have x plus 4 equals a negative 10. To get that x by itself, let's subtract 4 on both sides of the equation, leaving you with x equals, that's a minus 10 minus 4, that's going to be a negative 14. Okay, and for our last example, or excuse me, we have two more of this, excuse me. So for this, let's follow the same routine. We have x squared plus 5 as quantity, being squared equals 25. So if we were to square root both sides to get rid of the square, we're going to be left with the stuff inside that quantity. So we have 5x plus 5 equals plus or minus, since we're dealing with the square root function. And the square root of 25 is 5. So your function so far should read 5x plus 5 equals plus or minus 5. At this point, I like to break the problem down into two separate pieces of 5x plus 5 equals 5 and 5x plus 5 equals negative 5. On this first piece, let's start getting stuff away from the x by working farther away from it. So there's a positive 5 here. So let's subtract 5 on both sides of the problem. So we have 5x equals 5 minus 5, or 0. Now to get x by itself, as you see, 5 is being multiplied by 5, x keeping it there. So do the inverse operation of division on both sides by 5 to get x away. So we have x is equal to 0 over 5, or just x is equal to 0. For this other part of the problem, 5x plus 5 equals a negative 5. To get x away, let's work with this plus 5 first. So to the opposite, let's subtract 5 on both sides of the problem, leaving you with 5x equals negative 5 minus 5. Combining those will give you a negative 10. Now to get x by itself, let's divide 5 on both sides as we did earlier. So we're left with x equals negative 10 over 5, or just negative 2. With our next example, you'll see that we have x squared minus 19 equals 0. Okay, so what we can do is get x squared by itself, so we can use our square root property. To do that, we need to get 19 on the other side by adding it to both sides of the equation. Because as you see on the left side, the negative 19 and the positive 19 will cancel out, leaving you with just the x squared equals 19. Now let's apply our square root property to get x by itself. So square root in both sides. You're going to get x equals plus or minus, since we're working with the square root function, the square root of 19. And now what you can ask yourself, can 19 be broken down into any perfect squares, or can that radically be simplified? And it cannot. So the answer is x equals plus or minus 19. Or again, you can write that as x equals positive square root of 19 and x equals minus the square root of 19. Okay, in our final example in this problem set, we have the quantity x minus 2 squared equals 20. So to apply our square root property, let's take the square root of both sides, and the effect to cancel out the square root and the squared, and it's going to leave you with x minus 2 on the left side of the equation. Well, on the right side, you're going to have your plus or minus square root of 20. Okay, now you can separate this problem into two halves. So you can have x minus 2 equals the positive square root of 20, and on the other part you can have x minus 2 equals negative square root of 20. Okay, now let's simplify on this first part by adding 2 to both sides of the problem. And when you do that, you're going to have x equals, I like to bring the 2 out in front, plus square root of 20. Now there's only one more piece that you can do to this problem, and that is to think about simplifying 20. 20 can be thought of as the product of 4 and 5. And if you remember, 4 is a perfect square, so it can actually be brought out in front of the radical as 2, and you'll have to leave 5 inside the radical. So the final answer for this half can be x equals 2 plus 2 times the radical 5. Okay, and for this other piece of the problem, let's start solving for x by adding 2 to both sides. So we have x equals, let's pull that 2 out in front, minus square root of 20. Now just before, we can think of 20 as the product of 4 and 5. Remembering 4 is that perfect square, and we can pull it out in front of the radical as a 2. It's going to keep that negative with it. And we have to lay 5 on the outside, on the inside of the radical. So our final answer is going to be x equals 2 minus 2 radical 5. So for there you have 2 answers.